So it looks like we're recording
There
it.
we go.
All right.
The cloud somewhere in Northern Virginia.
Thank you, Dr. Gilden.
Coming in at 5 p.m.
All right, let's go. So let's do the round of intros. So Rahat and then Sylvia.
Hi everyone, my name is Rahat Sharif. I am a state science policy fellow here. And I'm here to help out, and I guess I'll pass it on.
Hello, I'm Sylvia. I'm assistant research scientist at the University of Maryland Center for Environmental Science.
Yes, and Sylvia will be making
I'm
a presentation today. Robin.
Robin Gilden with University of Maryland School of Nursing, and I am a commissioner.
Thank you. Belay.
Belay Demoz, physics professor from UMBC, member.
Wonderful. Don.
Don Bosch, a professor emeritus at UMCS and a former commissioner.
Jonah.
John Erlbacher, I'm a professor in the Department of Material Science and Engineering at Johns Hopkins University in Baltimore.
Thank you, Jonah. Suzanne.
Good afternoon, Suzanne Dorsey, Deputy Secretary, Maryland Department of the Environment.
Okay. Russ, you're on mute.
Russ Dickerson, Department of Atmospheric and Oceanic Science, University of Maryland, and a commissioner.
And currently in Germany.
Indeed.
Yes. Paulinus.
Good afternoon, Paulinus Chibu, Professor of Marine Science at the University of Maryland Eastern Shore.
Jared.
Hi there, Jared Williams, administrative support to the commission with the Maryland Department of the Environment.
Thank you, Jared. Rachel.
Good afternoon, Rachel Lamb, Senior Climate Advisor to the Secretary here at the Department of the Environment.
Thank you. Alicia.
Good afternoon, Alicia Bozic, just listening for awareness. Thank you.
Thank you. Kim. Oh, we lost you.
You're muted, I think, Kim.
There we go. Okay, I'll come back to you, Kim. No worries. Katie.
Hi, I'm Katie, and I am an advisor with the Maryland Public Service Commission, just staying updated on the related content.
Thank you. Alicia. Okay, we can come back to Alicia.
Apologies. Alicia Malky, manager in the Office of Resource Conservation at the Maryland Department of Agriculture.
Okay. Well, so we have an Alicia and an Alicia.
Oh, I'm sorry. I'm also an Alicia, and I was just listening for awareness. Thank you.
All right. Oh yeah. Okay. So I got you, the two of you mixed up. Sorry. Scott.
Hi, Scott Waitlovich. Also just listening in. Thank you.
Thank you, Scott. And Kim introduced herself in the chat, so I think we're all introduced. So again, welcome. Today we're going to have a presentation by Dr. Sylvia Santos da Silva with UMCS. I asked Sylvia to make this presentation, and it was primarily motivated by a little bit of my own curiosity, and I think also previous discussions that we had about when we, and particularly as I've been looking at the process of the MCCC over the last about last year. So I just turned my first year at UMCS as president and as chair of this group, as also member of the MCCC, and kind of watching the process and the state has ambitious climate change goals, right? And at the same time, there's these multiple possibilities of how to achieve those goals, multiple policies, lots of state agencies, embedded in a national context, embedded in a global context. And prioritizing investments in a time like all times, but particularly now, a time of scarce resources, prioritizing becomes a daunting task on one hand, I think, and then on the other, it's it's a little difficult and complex to sort out all the different priorities. But there are tools out there that allow to try to visualize, if we implement, such policies over time, this can happen, and also coupling that with the fact that some of these tools are developed in-house here in Maryland, right? We have a very good policy modeling group at CGS at the University of Maryland College Park, and they are co-creators, co-developers of the tool that we're going to discuss today, which is the Global Change Analysis Model, GCAM. And I remember from my prior time at the STWG, I've mentioned this before, that the Joint Global Change Research Institute at UMD and PNNL, they had membership actually on the STWG from a time back, and maybe this is we can consider re-asking them too, because I know Ghasim Asrar left the institute, and then I don't know that we've had representation from the Joint Institute since that time. So anyway, long story short, GCAM has evolved. There's a GCAM USA version that was published maybe 2 or 3 years ago. The model allows to do analysis at the state level, and there are some interesting insights. So Sylvia's been working on GCAM modeling for a while, long time actually, since you were a doctoral student at University of Maryland at AOSC, and the department where Russ is in and where I was at the time. I asked Sylvia to take a look at GCAM USA and Maryland and try to see just what the results of the kind of reference or base case scenario are, and some policies that have been run with that model and what those say for Maryland, with the hopes that this could become, or something like this could become a tool that the state could use to analyze and prioritize policies and investments in climate change. So that's a little bit of the framing of this conversation. Sylvia has a good presentation to go through, and hopefully that will stimulate some great discussion, and we can see where we go next. Does that sound like a good plan yeah, sounds good. So Sylvia, let me ask you to take it away from here, and I asked Sylvia to make a presentation, then we can have a little bit of Q&A around it. So Sylvia, the floor is yours.
Okay, Fernando, thank you very much for the introduction and for the background. Can you hear me well?
Yes.
Okay, yeah, I'm going to share my screen. So let me just one sec here.
Yeah, and I made you co-host, so you should be able to share.
Should be coming soon.
Mm-hmm.
Are you seeing?
Yes.
Okay, let me do something. Okay, so where's one sec? Okay, can you see the slide, the pointer? Is everything well here?
We can see it. Yeah, we can see the slide. We can see the pointer. Yes.
Okay, good. Yeah, thanks for the introduction, Fernando. I'm Sylvia, Assistant Research Scientist at ANSES. Like Fernando says, I've been working in integrated assessment modeling for a while, since my doctoral studies. I'm a proud alumni at the University of Maryland College Park, the Department of Atmospheric Oceanic Science. So today I am going to talk about integrated assessment modeling of energy, water, and land system scenarios for the state of Maryland using this framework that Fernando has already mentioned, JCAN USA. So we believe that this tool and all these topic has strong synergies with the objective of this group or this working group. So that is what we're covering today. This outline, a quick background, the tool itself, JCAN, and we are particularly interested in JCAN USA. Then, like Fernando said, we are going to take a look at some illustrative scenarios for Maryland. I'll talk a little bit more in a while and have some key takeaways. I hope this can foster some discussion around this topic. So just to give you some initial context, I think it's not surprising for all of you that our modern society are strongly dependent on food, water, and energy resources, and we are using these resources extensively, particularly during the last decades. And because of that, we are changing climate is changing. And in consequence of that, these same systems are vulnerable to the climate impacts, and humans and our society is vulnerable to the climate impacts. So understanding this problematic is not simple because all these systems are strongly interconnected in non-linear ways. So this is the main reason tools like integrated assessment models were developed. So the main objective or of these tools are to analyze these interconnected challenges, so feedbacks and interactions across these systems. So these models emerged in like late 70s or early 80s. At the beginning, they were relatively simple, kind of in the interface of energy and climate, emissions and consequences for global warming. But over time, these models are evolving and accounting for other systems like water, food, and allowing the exploration of a range of other questions in the energy, water, land nexus domain. So we are going to I'm going to show a few examples soon. But like we mentioned, the IAM's integrated assessment models explore how human development and societal choices interact. So, for example, we can understand how socioeconomic development or our choices in terms of preference of the use of energy fuels can affect the climate. These models include representation of human and earth systems, and these models have been used a lot in the climate change science. For example, several reports, IPCC reports, rely on hundreds of scenarios developed by different integrated assessment models in chapters related to climate mitigation, and more recently also to climate adaptation. And they are useful to understand, for example, solutions, trade-offs across these systems. Also, several analyses from integrated assessment models have been used to analyze consequences of international agreement like the Paris Agreement and so on. So this is a simple schematic of idea behind IAM. If you are not familiar, they generally will have some representation of the economic system and the other system like agriculture, climate, energy, water, carbon cycle driven by external data. But they are, in a sense, type of what-if models. So the outcome that you have is largely depend on the questions that you are making, and it's particularly what inputs you are making to the model. So if you are exploring, let's say, socioeconomic narrative, high population, high economic growth, or we can explore different technology choices, different policies, climate policies or policies across sector, resource availability, constraints in resources. So they are what we typically call conditional forecasts. So we're gonna see a little bit more of these in a while. So this type of multi-sector human Earth system models are developed by a few groups around the world. There are not many IAMs around, but the one that we are focused today, like Fernando says, is developed by the Joint Global Change Research Institute in College Park, Maryland. So it's the GCAN, is a well-known IAM in the field. So just some overview of this model specifically. So GCAN model these 5 systems explicitly. So representation of these systems and their connections. And allowing, so like we are saying here, the exploration of several questions in the interface or interaction of this system. It's also important to note for GCAN and also for integrated assessment models in general, they are not meant to explore any of these systems in a high level of detail. So the main focus of this model is on the interaction. So, and also to get the main insights to support decision-making, but over long-term horizons, several decades into the future, mid-century, end of century. And also they are on purpose. This is also on purpose to keep data tractability. We don't want a model that runs for days or weeks. We want to have some quick assessment and about insights on these systems. And just to complete here our overview is a multi-sector model that runs using a type of economic framework, but within that this economic framework, there are representation of physical systems, energy, agriculture, land, water, supplies and demands are represented in the model. There's a lot of data-driven this model. It's similar to what we have seen before. Outputs is driven by what we are assuming in terms of scenarios. And importantly, this model has been used a lot in IPCC contest. By the way, GCAN, together with other IAMs, has supported the development of scenarios that are widely used in climate change research. So the representative concentration pathway, share socioeconomic pathways. If you are interested in using this model, it's open source, community model, you can download using here. You can also contribute to the model. You can download the source code, contribute to the development of the model. And just to close here, the model runs in 5-year time steps. You can run it until 2100, but here we're just showing mid-century results, but you can run at the end of the century, and it's calibrated until 2015 in this version that we are showing today. But last month, June, a new version was released and the calibration was standard until 2021. So if you download the new version, this was upgraded. So calibration means that outputs of GCAN are consistent with historical data. So, the calibrate, just to give you a sense. An overview what is inside GCAN. So we are not going to go over each of these because there will be a lot. Each box could be, that's a lot of information and assumption behind it, but to give you a sense, GCAN model supplies or energy, water, land resources, also demands, and the demand of energy, water, land, food depends on socioeconomic, the population, income, and then in the economic framework, the solution is found when we have balances between supply and demand. All activities in the model emit, so we have emissions of several greenhouse gases and species tracked by the model. And because we have a simple climate model embedded in the model, we can convert these emissions to concentration, to radiative force, and understand implications, for example, for global warming, temperature change, And some of the outputs are listed here. We're gonna see a few examples of these in the results, but just to give you a flavor of GCAN. And in terms of spatial scales, GCAN divides the world in 32 regions, energy economy regions. Just a note that this has also the new version last month upgraded these now to 33 regions, because now we have Ukraine as a new region in the model, but I'm using the prior version. And we have water model at the main 235 for the basins, land 384 regions, and 1 climate system. This is the core version, but because there has been need of more regionalized integrated assessment, so over time, other versions have been developed with a higher focus in certain regions of the world. So that's why we have GCAN USA, we have GCAN China, we have Latin America and Caribbean, Middle East, North Africa, Saudi Arabia, GCAN Chile. There are others, but we are focusing here on GCAN USA. So like I told you, GCAN USA is a specific version, is a version of GCAN, but with more detail over the USA, and is by far I would say the most developed version across all that regional versions. Is by far the most developed because it's constantly updated yearly. So yearly, GCAN has been upgraded and developed, and also GCAN USA, because GCAN USA is part of the GCAN framework. When you download GCAN, you also download GCAN USA. We just need to turn on the GCAN USA, but they when you download, they come together. And the difference here, we'll have the same in GCAN USA, you have the same geopolitical regions around the world, but rather than having a single USA, like in the core version, you have each state individually model in GCAN USA. So that's the advantage, so that we can have more detailed state level analysis for states. So we have more detailed representations on across socioeconomic and energy in particular. And just to give a summary of what we have in terms of capabilities, we have more details, state level details, socioeconomic, energy, water demands, GCAN USA. For the land and water, we do not have state level detail. We have subnational. They are modeled at these river basin level, consistent with the USGS boundaries. So Maryland lies in the mid-Atlantic basin. So these are for the land system and for the water supply. So these are the spatial scales that we are dealing in this model. And to close this, I just want to illustrate a prior application of GCAN USA, a paper that used GCAN USA to evaluate the trade-offs between climate change and water scarcity. So in a scenario, we have two climate scenarios, one, a no climate policy versus a mitigation climate policy. And basically it's saying that under climate policy, water scarcity tends to increase, particularly in this region of USA, because of the larger use of water to irrigate biomass. So basically highlighting, at that time, this is one of the first few studies highlighting these trade-offs between climate change mitigation and water. And this is possible because GCAN includes water as one of their systems. Yeah, and now we are shifting to the interesting part when we are going to see some illustrative scenarios. Just to give a note, these scenarios were not developed, like Fernando mentioned earlier, they are not developed exactly for a Maryland context. They were developed for national level analysis, but we are trying to look at these scenario results and to try to get some insights for Maryland. And we hope that we can help us to move on to a more specific scenario analysis focus in the Maryland context. But just keep in mind that this was not, all the results that I'm going to show was not, scenario framework were not developed for Maryland specific context. But using those illustrative scenarios, we try to, what we are trying to look in terms of questions are listed here. So for example, how will the state of Maryland's energy, water, land sectors co-evolve in the context of human and earth system forcings, such as socioeconomic and climate policy, or which sectors and policies could experience energy, water, land trade-off and conflicts, or synergetic opportunities, and how can investments in energy, water, land system at the state level be prioritized across economic, social, and environmental impacts. And the scenarios that we are going to be looking at, first, socioeconomic change through the shared socioeconomic pathways, a reference, which is largely SSP2 scenario. And this is where most of the results we're going to be in a climate policy, basically a net zero target. So am I going okay, fast or slow? How things are going?
Yeah, we're still breathing, no worries.
Okay, thanks. So yeah, just to give you, for those, this should be familiar to many of you, but for those that are not familiar, shared socioeconomic pathways were developed by the climate change research community, are trying to, let's say they are kind of visions about the future of our society. So basically 5 different futures of societal development that can span different challenges for mitigation or for climate adaptation. So for example, we have an SSP2 middle of the road narrative that basically assumes that the world current trends, the world will evolve similarly as historical trends. Or we have other narratives that are more extreme, like SSP5, that are highly fossil fuel development or rapid economic development, consumerism. So each scenario has a narrative that is described in the literature. This is a sustainable scenario, progress towards sustainable development. So really, that is really an entire narrative behind these scenarios. And when we ran the SSP scenarios and look at Maryland, specifically using GCAN USA, it's interesting that we can see showing here results spanning each of the system, energy, water, land, and emissions. We can see as the outcomes for Maryland can be very different depending on the socioeconomic assumption. We can, for example, this is electricity generation. Compared to the 2015 present level, we can almost triple our needs of electricity in one, like SSP5, versus kind of doubling by mid-century or below. So we have a large span of difference between how much electricity we need by mid-century, depend on socioeconomic. This is the water demand, water withdrawals. Also, we have a kind of a gap by 2050 in terms of how much we are going to use in terms of water. Land system, you also evolves by different. This is agricultural crop production, and depending on society, or we are using more resources, or we have high population or high GDP, we will need more food to feed that population. So this means a lot in terms of how much crop production we're going to need by the end of the century. And because of that, we have implications for climate. When you look at fossil fuel emissions, this is interaction energy climate. You can also use the land use CO2 emission. You can see that it has a high gap, high difference. So not surprising here that SSP5, which is the fossil fuel world, is the largest. So yeah, so this is just to give you a sense that just socioeconomic alone, changes in socioeconomic have large implications for the future of energy, water, and climate system in Maryland. I will start defining what we are calling reference scenario, because we need to understand these to go to the next and final section of the net zero scenarios. And reference scenario is a scenario that can be used as a starting or reference point for comparison. And in the context of JCAN USA reference scenario, it's basically assume a continuation of current policies. It's basically an SSP2 narrative with no effort to mitigate climate change. So this is reference scenario. I'm going to give a quick overview of what the reference scenario means in terms of some outputs for Maryland. In terms of socioeconomics, very briefly here, the reference scenario assumes a steadily growing U.S. economy and population. This is USA and Maryland. And note that the axes are different, but it's basically growing population and growing GDP. Also, we have different, just to note the different axes here, but basically we have for Maryland an increase in 22% by 2050 relative to 2015, and GDP 86%. If you want more details about assumptions, they are all listed in this paper. And use energy. Generally, all demands in JCAN are highly dependent on socioeconomic. If you compare the final energy consumption USA versus Maryland, and also again, I have different axes here. USA is increasing due to the socioeconomic forcing. In Maryland, we have some small decline projected by JCAN, and it's largely because of the transportation sector. If we split here the colors by the main sectors, see that consumption, the transportation sector is projected to decline. We're gonna see a little bit more ahead, but just to give you a sense on assumptions in reference scenario, assumes a continuation of current energy efficiency standards. So whatever efficient standards were in place until the calibration is basically carried out by the model. There's no intensifications, just to be clear, but the efficiency carried out. And the transportation sector takes a little bit less of final energy consumption by 2050. This is the use of energy, but by sources of energy, and you can see for both USA and Maryland a tendency or more electrification, which is this electricity here is gaining more share by 2050 relative to present level, and a little bit less on the refined liquids. And this is largely because several sectors are electrifying over time. We have buildings, new demands in buildings, new demands in the transportation sector, like in light-duty vehicles that are electrifying. So, and also note that JCAN USA reflect policies to incentivize electric vehicles. And in terms of power sector, because we have a growing and population, they may have needs of more electricity. That's why we have growing demands over time for both growing production over time in USA and Maryland. Largely USA based on fossil fuel, but we have some growth also renewable. For Maryland, large natural gas and also some renewable. Also important to note, all it's always important to understand what's behind this, because like I told you earlier, there are several, these models are kind of what if models, and that depends on what we are assuming. So for example, we are assuming no new deployment of coal-fired power plants in line with the Clean Air Act section. And also there are some limitations on nuclear in the model. So that's why nuclear cannot develop significantly by the end of the mid-century. And talking a little bit about emissions, I think it's not surprise for any of you, and this is in USA, not Maryland yet, but USA, that most of emissions in the USA have been dominated by CO2 emissions from energy and industrial. If you look at this chart, the historical period, you're gonna see the most of emissions, greenhouse gas emission in USA has been dominated by CO2 for the energy sector, and largely electricity and transportation. Just to give you a sense of what the JCAHN USA is showing for USA as a whole. We have some increase, but this increase is driven by emissions in other sectors apart from fossil fuel, which is not increasing significantly in the reference scenario. For Maryland, also it's not surprising because, not surprising to many of you that Maryland is not among the main emitters around across the country. Big players, if you look at this distribution across states by year, you're going to see that big players are California, Texas, and Maryland will typically rank between, depending on the year, between 29 or 34. And here we are looking at the profile of emissions over time projected by JCAHN USA. Fossil fuel CO2 emissions are projected to decline by 2015, largely because one, the transportation sector, with here, when we split by sectors, largely because of the transportation sector. And here, on the other hand, electricity, emissions from the electricity project to increase. And another insight is water. Remember, JCAHN tracks water demands. We have USA versus Maryland. And also this figure shows total water withdrawal by sector and splits. The split here by sector is shown here. We have some modest decline for USA as a whole by 2050. And largely because water for the electricity sector is declining, as you can see here. But at the same time, we are demanding more food. Because of that, we need to irrigate more. That's why demands for water are increasing. And in Maryland, we also have a similar trend in terms of emissions from the electricity declining. Main water consumers are electricity and municipal. Irrigation is not the main source of demand because Maryland is not a heavy agricultural state, so that's why demands are relatively small. And just to give a sense of why these demands in electricity are declining, is because this is a explicit assumption in the model that technologies for thermal cooling in power plants are improving. Basically, we are replacing water-intensive cooling systems by less intensive cooling systems over time, and also some shift toward less water-intensive generation technology. So that's behind what is driving these. And then we go to the section about climate policy, net zero scenarios. This is an interesting part. And please note that these results are not does not reflect any new action of the current administration concern the climate, the Paris Agreement. So the results were generated prior the current administration. But coming back to this, so most of you may know that during the 2021 United Nations Climate Conference, the US announced its goal of reducing net greenhouse gas emissions by 52%, 2030 relative to 2005 levels, and of reaching net zero emissions no later than 2050. We can see in this illustrative chart the projected pathway in terms of emission for 2030. And also another goal was to achieve 100% carbon pollution-free electricity by 2035. So basically, JCAN USA was employed to understand the implications of the net zero scenarios of the climate goals of the US at the state level. So this scenario framework was originally developed by a study by O et al. 2033, in which they used JCAN USA in 4 different US net zero decarbonization pathways, and explicitly assuming these 2 national targets. A long-term strategy aiming at 50% net reduction in greenhouse gases by 2030, and net zero greenhouse gas emissions by 2050. So these were one target, and another target in this modeling approach is that the power grid achieves clean grid by 2035, meaning no fossil fuels in the power sector in 2035 and after that. And also they developed one central net zero scenario and also some variations across scenarios, because to account for uncertainties in terms of low carbon technologies, carbon removal technologies, and also behavioral changes. It's basically this table, which basically what this means is that we have one net zero central scenario, and we have all technologies that JCAN have available, including carbon dioxide removal like CCS or direct air capture. We may be somewhat concerned that these technologies are relatively new and not so mature, but JCAN's a technology-rich model that accounts for all. We have also a clean grid target, like I told you earlier, and also the net zero scenario has an incentive to increase terrestrial carbon sinks. This is basically what this means. Terrestrial carbon sinks are increased. And we have some variations, no CCS. Basically, in this scenario, we do not allow CCS. We have a low LU, land use carbon. Here, we are not stimulating terrestrial carbon sinks to the same level of the original scenario. And these will have low demand. Net zero low demand means that we have low demands in the low energy demands, and also some pricing in non-CO2 emission, which means that basically we have also less emissions from sectors outside the energy, like agriculture, for example. So just an overview what these scenarios mean. First, for USA, I have showed you the historical plot with significant amount of emissions and largely from energy, but this is the projected by JCAN USA for 2050 across all the 4 pathways. We all reach net zero with some level of residual emissions, because these are for sectors that are hard to abate these emissions, and that's why we need carbon dioxide removal strategies to compensate for what we cannot abate. So it basically means, and we have some variations, it basically means that whatever we have here on the positive, we need some CDR to compensate for, which could be a terrestrial carbon sink or bioenergy with CCS, which is this light green, or even a new technology like a direct air capture to compensate for these residual emissions. And this is USA. Let's start taking a look at Maryland, some implications for Maryland. So if you compare fossil fuel emissions by 2050, you see a significant drop in fossil fuel emissions by 2050 compared to the reference scenario. The net zero and all variations are here. So it is a major drop. And so I think it should be familiar that most of the emissions in Maryland are CO2 presently. So we have the net zero, we drop their emissions, but this has a lot of implications. So reaching to these will lead to significant economic and sustainability consequences. Let's see a few of those things ahead. Well, let's continue showing a little bit of results in fossil fuel, but split by different sectors and also in the transportation sectors. In the reference scenario, I think I've shown these before. I think, no, not this figure, but we have fossil fuel split by the different sectors. I'm sure I have mentioned earlier that transportation sector is reducing over time, total emission, electricity somewhat increasing. And in the transportation sector, is projected in the reference scenario, not net zero yet, reference. We still have by 2050 some liquid fossil fuel, and I split between hybrid, electric, and hydrogen vehicles. But when we compare with the net zero pathway, this is fossil fuel CO2 emissions. We see that we will need, in this net zero scenario, we will need a significant larger drop of emissions across all sectors. So for example, we need to stop using, we need to drop significant emissions in the transportation sector, all sectors, and also we need some CDR also to compensate for certain emissions. So with some variations across the different sectors, but all of the scenarios show major reduction in fossil fuel with profound reductions in power and transportation sector. You also may need, like I told you, some CDR options to compensate for emissions that are hard to abate. In the electricity sector is interesting because it really calls attention. The magnitude of changes is profound. So if we compare the reference scenario, we can see that we're gonna need to produce significantly more electricity because to achieve the net zero, we will need to stop using fossil fuels across many sectors and replaced by the use of electricity. So, but for that, we need to produce much more electricity than in the reference scenario. So we have variations depending on the pathway. So in the net zero, we have considerable reliance on CCS technologies. We have no CCS. So if we do not have CCS, we're going to need to compensate with more of other low carbons, including nuclear, and a little bit less in low demand because it's a low energy demand scenario. But in summary, we have a massive shift toward electrification, extensive adoption of low carbon technologies. Possibly, we'll need carbon removal technologies, or we need to compensate with other low carbon sources. So all of these obviously have significant financial implications because we have it's significantly large, the amount of investments that we may need, And also may need to retire some fossil fuel facilities earlier than the operational lifetime. It also had implied losses, financial losses. This is a comparison for the transportation sector. We can see in the net zero scenario, really we need to increase a lot. Our modes of transportation, we need to rely significantly more on electricity or hydrogen fuel vehicles. So the difference is very large relative to the reference scenario here. You can see it by the colors, the electric and hydrogen. Also, we need to, the hybrid also need to be reduced a lot relative to the reference. So with some variations depending on the scenario, but this is the main takeaway. We have told you earlier that we have financial implication, but also have other implications outside the emissions. So we may have some co-benefits in terms of health. So that many of you should know that exposure to fine particulate matter, PM2.5, is associated to mortality. So in the net zero scenarios, if we compare here emissions of particulate matter and also its precursors, we can see a major drop across all pathways. So this is NH3 by 2050, NOx by 2000 is reference blue, and the other scenarios, PM2.5 itself, and SO2, also major drops. So this means important co-benefit in terms of health. So larger reduction in major air pollutant, largely because we are decreasing fossil fuel use and increased electrification. So these are the consequences for health. There are also consequences, other co-benefits for the water sector. If we compare to the reference scenario, all scenarios are showing less water demand, and largely from the power sector, because we are replacing water-intensive thermal technology by less water-intensive, particularly renewables. So that's why this drop in the power sector water use, which is a beneficial aspect. And just to close this presentation and our key takeaways, we want to highlight that we see typically some sector-specific analyses that do not consider energy-water-land interactions. So we have shown you in this presentation some various examples of why we should consider the interaction. So these systems are highly strongly connected. So consequences in one, changes in one sector can largely affect other systems. So that's why we need a framework to identify these trade-offs and synergetic opportunities. One tool for that we introduced today is GCAN, and a version of it, GCAN USA, for larger resolution at state and subnational. One key takeaway that we could see that various driving force can shape the future of Maryland energy, water, land sectors. Socioeconomic alone could drive substantial changes in demand across these systems. We also saw that ambitious climate policy could present co-benefit. We saw examples of water, demand, health, but there is a lot in terms of financial implications can be large while implementing a net zero target. We have shown that GCAN USA can support the development of state-level policies. Like I told you earlier, the scenario framework was not developed specifically for Maryland context. This could be done in another exercise and a more robust scenario analysis and focus into Maryland-specific questions. So GCAN allows several possibilities in terms of socioeconomic, technology, cost, availability, penetration, air pollution, climate change impact we have not explored here, but we could analyze, for example, implications on water supply, because GCAN is coupled with a hydrology model, a simple hydrology model, but it can give insights in terms of carbon impacts on the water sector. GCAN USA results could be coupled with other final scale, sector specific, and we see a lot of synergies with other efforts being done across the state. That's starting with this commission, but there are other initiatives going on that these GCAN USA can align with. And given that, we'll stop here. So hope that you're not get scared with that many level of details. So but we try my best to simplify for those that are new, but hope that is useful. I'm open to any question. Thank you.
Thank you, Sylvia, very much. Let me open it up for questions, comments. I know there were a couple of questions in the chat related to health. I think Sylvia touched a little bit of base on that, but certainly we can dig deeper as well. So a question from Russ on whether this included plans to close some facilities. The answer to that right now is no. This is really, I mean, right now these results are basically the GCAM calculation is supply, demand, pricing, not intervention specific.
Yeah, it does not include any specific policy for Maryland. Well, apart from the main policy like the Clean Air Act, but not any other specific Maryland policy.
Right.
But this could be, sorry.
One of your slides seemed to indicate a substantial decrease in electricity produced by nuclear, and I'm unaware of any plans to shut down Calvert Cliffs. So maybe I misread it.
In which one?
Yeah.
Well, not like it. We're not. These results are not specifically framed for Maryland contest. This could be done in another separate exercise, and probably interesting would be to have a scenario, which I think is probably missing in that O et al. Analysis, probably a more limited nuclear development. But there's no specificity toward Maryland specific. It's largely driven by the general GCAN assumption.
All right. Well, let's go into the questions. I have Alicia, then Victoria, and then Jonah.
Thanks. Yeah, could you return to slide? I believe it was 26. There was a bullet I wanted to revisit.
26. Okay. All right.
So the last bullet on the larger contributions from ag and forestry, can you elaborate on what that's coming from for me?
Yeah, because we see here total greenhouse gas, all sectors, all emissions here. We have fossil fuel. We see that fossil fuel are kind of, it variates, but it's not increased by 2050. And this growth comes from the other sectors outside CO2. So one contributor is the follow. But I'm not plotting here, but it's like NO2, SH4 for agriland use, and largely because we need, like I show in another plot, needs for food are increasing. So we are planting more, we are emitting more on this side. Yeah.
Thank you. And then my second question related to assumptions for crop production, fertilizer applications. Are those outlined in the link that Rahat put in the chat, or where would we understand that a little more if I'm interested?
Well, I have, is that something in the chat I haven't seen?
I
But,
linked the GitHub website that you posted.
So is that where I would
oh,
read more about the ag sector?
yeah,
assumptions?
in the JCON
Yes.
documentation, also in the publication, there are more about the ag, but yeah, fertilizer is accounted for in GCON. Yeah, the assumption about fertilizer user, I won't be able to elaborate that much in exact terms, but yeah, it's assume a certain use of fertilizer in the ag sector.
Specific to, you mean nationally? I'm assuming Maryland level assumptions are not in that document?
No, it's a general document for GCON assumption as a whole. Yeah.
Okay, thank you.
It's not, there's no Maryland specific in that document yet. So unless we develop something soon.
Yeah, so I think that so these are not, none of these results at this point that have been presented for Maryland are due to Maryland specific interventions.
Yeah.
Right? So, but that doesn't mean that we could not introduce those. So part of having this talk today is to possibly move in that direction where we have a tool that would allow us to explore Maryland specific interventions.
Exactly, yeah. So trying to, like Fernando said, demonstrate some of the capabilities of the model in terms of modeling this key energy, water, land, climate interaction. But yeah, that definitely can be tailored to a more Maryland specific context.
Yes. Like closing, like what Russ was mentioning, closing a facility, or opening new facilities, and
Yeah,
new
definitely.
investments. Yes.
Yeah, definitely. Yeah.
Yes. Yeah, let me move to Victoria and then Jonah.
Awesome. Thank you so much for this really exciting talk, Sylvia. I really appreciate it. I'm sure we all learned a lot. So I had a question. Fortuitously, in some ways, the model was tuned to the time period up to 2015. And so we now have 2 5-year periods following that. And so I don't want to ask you about Maryland, but I noticed that a lot of the figures you presented show very strong trajectories in those first 2 5-year periods, strong decline, strong increases, really pretty radical departures that sort of stabilize into the future. Has the US kind of broader energy use, water use, kind of moved along the same trajectory as those 2 periods in the GCAM model?
Do you want to point out one specific example? Well, if you are talking about the net zero, but net zero is a very ambitious target. So yeah, the changes.
No, I mean, even in the base,
The
even in the
reference.
base scenario, we saw, I think, and of course you presented Maryland, and I think it's unfair to ask you about Maryland since it hasn't been tuned to Maryland, but really there were some very strong changes in energy use and water use in the early 2 decades or 2 pentads. And those we could check because we have the data to assess how the model does. For example, here, as you say, well, there's a decline in the USA electricity generation, and then an increase. I'm thinking just about, to what extent the model. I mean, and if you don't know, that's totally fine, right? But because there are 2 time points, it's actually possible to somewhat validate what the assumptions in the model, how those have been followed for the base and the scenarios. So,
Well, oh, sorry. Go ahead.
No, I mean, I have the sense that we don't know the answer to this exactly right now, right? But it would be fun to look at that and see.
So yeah, so the one comment I can make, and that's a great question, by the way, and the model has only been calibrated through 2015, and it needs to take this data in. But the one thing I'll say, for example, for the US, or the plot on the left, and for the periods 2020 and 2025, is that the share of renewables being used to generate electricity at the national level has gone up. in the past decade. So you can see wind and purple and solar in yellow have grown over the last decade. That has been the case. That's validated by data. Whether the actual percentages are exact, that needs to be, recalibrated. But at least the trends, do show some correspondence.
And also the calibration was updated. So the latest version of the model is calibration stops at 2021.
Okay.
So because this
and
is
that's great, but it doesn't allow us to validate, right? Because
Yeah,
we don't
yeah.
have 2026.
Right.
So I kind of
No,
love that you're using this
2021.
version.
No,
Oh,
I
I
mean,
see.
the
Yeah.
The
Yeah, so-
calibration was updated to 2021 in the newest version. That means that historical data, it means that the model replicates in historical data, which is good. But here, 2020 is, let's say, projection year in this version, and demands in the model are largely reflects of socioeconomic assumptions. Oh, there are many assumptions in the model, but one driving force is the socioeconomic assumptions. So.
Right. Well, I'll just point out that, as you know, right, that you have your training data and your testing data is the future. So we don't have a future point for the recalibrated model yet. But the other thing I just wanted to point out that this could be a really exciting tool for investigating, for example, server farms, right, which are a massive energy and water use. And I think this could be very interesting to apply to that problem, which is clearly not in the current analysis, because we wouldn't see the numbers that we see now. Thank you.
Yeah.
Thank you. Okay.
Jonah?
First of all, thanks for a great talk. Really interesting. And I think this model is really worth looking into in a lot more depth. So I really appreciate that. My question really is nitpicky in a sense. Maryland, especially looking at the electric power sector, Maryland imports quite a lot of its electricity, something like 40%. I forget exactly what the number is. So when we're analyzing Maryland, we're analyzing its future. Are we including the imports of electricity and accounting for their emissions appropriately?
Yeah, the trade of electricity is accounted for by the model, but it's not in this plot. This plot is
in the sense of, if you look at Maryland specifically, if electricity is generated in Pennsylvania and is emitting in Pennsylvania, I still think it would be fair for us to account for the emissions associated with that electricity use that's imported into our state. See what I'm saying?
Yeah.
The trade
when we're parsing it at a Maryland level.
Yeah, trade of electricity is accounted for in the model. I would have to take a look depth into details of the trading. But on the positive side, I can tell you that the electric power sector is definitely by far the most detailed sector in JCON USA. It's probably the one that they have invested a lot. But all activities in the model, emissions are tracked. I will need to take a look depth into the trading assumptions. But yeah, the electricity trade is accounted for.
Yeah, and how they were accounted for state to state, right? So
yeah,
right, exactly.
I don't know the answer to that question, but it's a great question to explore for sure.
Yeah, sure.
Yes.
Well, thank you very much. Appreciate it.
Very good. Yeah. Any other questions? And while we get any more questions, so I think the purpose of this was to kind of illustrate, tool that's available, that's open source. It's actually developed here in the state, where we have a lot of competitive advantages in terms of knowledge. We have a big group at College Park that does this analysis, not only at Maryland, University of Maryland, but also at the Joint Institute. So it is something that we could explore in terms of using for the state as a tool for planning and management and trying to visualize in how different policies interact and play into the future. That's a little bit of the spirit of of doing this.
Yeah, I think there's a lot of potential the application of this module for Maryland contest. Yeah, that's true.
Yeah, but Sylvia, let's try to. I'd like to get an answer to Jonah's question, maybe other of the questions that have been raised, and try to just try to get some feedback.
Yeah, sure, yeah.
Yes. Well, I think why don't we move to the next item on the agenda? So thanks again, Sylvia, for the presentation. And we have 15 minutes, and I still want to do open some space for public comments, but I wanted us to get thinking. We're in July, and this is the part of the year when, after July, things start accelerating towards the fall, or we have to do the recommendations and the annual report. So that's right around the corner. And since Jared is here, I'm going to ask him to remind us of when our recommendations as a group are due. I think it's
Hey there,
August.
Fernando.
Is it August or?
So September 1st is the due date for working groups to submit their recommendations to the commission. So, clock is ticking.
Yeah. So yes, clock's ticking. Some good news is that we do have a new template to develop the recommendations, which is streamlined, and hopefully that'll allow us to submit our recommendations more quickly. But I do want to spend, and we'll start now, but definitely the August meeting, talking a little bit more specifics about recommendations and getting those drafted and submitted. Don, you have a question? Oh, you're muted, or we're not hearing you.
Yeah, could you let me share my screen and help me talk?
Absolutely.
Okay.
Let me look you up and make you. Should have done this with everybody, but let's see. Yeah, you should be able to share now. Speech.
Can you see this, anyone?
Yes.
Sharing it? Okay, great. This follows the conversations we had at a couple of meetings, and this is, remember this whole thing with the commission, Maryland Climate Change Commission started with a couple of big assessments, and one of them is the climate impacts assessment that was done in 2008. And I just wanted to show this in terms of the sort of the gold standards of assessments we do on a global basis, the IPCC, as well as what the US has done in terms of national assessments. And the first point I want to illustrate is that we did this back in the early days of these assessments. And so there have been 2 major IPCC assessments and 1 in planning and about to begin, and then 4 national assessments. So my point is, there's a lot for us to build on if we do a Maryland-based assessment of climate impacts. And then second with that is the last meeting when we were discussing the Mesonet. We discussed the better capability, both in terms of observations, in terms of downscale models that we have now, and in terms of understanding the variations within the state. And so that it may well be something that's time has come for us to pull this together and do this kind of assessment. But maybe we can do it actually fairly simply by building on these existing tools and so on. We had Victoria join us at the last meeting, and she helped. She was our go-to person for the downscaling for the way back when in 2008. So we have much more capability. So I am thinking about where this leads. It's not something you can do, in a month or even half a year. It's going to take longer. So the proposal is that maybe we should develop a brief proposal as part of the recommendation to the commission and get buy-in from the commission and maybe participation by the other state agencies in doing this, and maybe even some funding for it to make it happen, say over the next year or so after then. Also related to this, you should know 2 things. First of all, the Trump administration has closed the U.S. climate change research program and there's no intention to proceed, even though it congressionally mandated, with another national assessment, climate assessment, and has not nominated U.S. scientists to participate in the next IPCC. However, a group of coalition of scientists in the American Geophysical Union have nominated a whole list of U.S. scientists to participate in the next IPCC, and some of them are already getting invitations. So it looks like through that process, there will be U.S. scientists participating in this next IPCC assessment, which is due in 4 years from now or so, 5 years or whatever it's going to be. So anyway, that's the gist of my proposal, continuing the discussion we had before with some ideas that we can maybe translate to a 1-paragraph proposal to put on the recommendation.
Absolutely. No, thanks. Thanks a lot, Don. And yeah, and if you think about, the work that was done before, the downscaling work in the scenarios that Victoria led, these modeling capabilities coupled with the improved monitoring capabilities with Mesonet. So there is a convergence of new tools that we could use to provide this major update. So I really look forward to having a conversation around recommendation along these lines, because I think it will be a very, very solid contribution, from this group for sure. Well, let's see. Maybe a few minutes for public comment. Do we have any public comment? Oh, it sounds like we do not.
Yes,
go ahead. Any other comments?
This is Russ. Just wanted to make sure Sylvia knows that the last official, meeting of the commissioners of the Climate Change Commission, the comptroller of Maryland presented what are the economic ramifications of climate change for us. We're focusing, of course, on the financial. So I have not been able to get my paws on that PowerPoint, but I'm sure we can get one, and that would be something you'd like to have in your inbox, Sylvia.
Yeah,
Yes.
thanks.
It was sent out in the notes from beforehand. I didn't get the one that has the one that they gave the where are we now and where are we going. Thanks, Jared.
Yes, so I know that the controller's presentation is in the MCCC website, and so it's there, and it was mentioned in Sylvia's one of the last slides in terms of synergies and effort. So, and that's a little bit of another motivation, right? Because we have these different efforts, going on, and to bring some coherence to these, and with the Mesonet and the economic financial analysis and the new data and the downscaling. So there is a big opportunity here for us to have a very, very solid contribution. So I look forward to converging around that idea.
Yeah, thanks. Yeah, I see that there on the chat here, the link. Thanks for the links. Yeah.
Oh, okay. Yeah. Well, it's a state spending series, climate change costs. Okay.
Thank you. Yeah.
But it doesn't include the increased costs for healthcare due to the pollution and heat waves coming with climate change.
Yep.
Those are very local. And the benefit of actually, if we do our part and reduce, stop burning fossil fuels, or at least stop burning so much, there will be substantial benefits to the citizens of Maryland that'll save us money.
Yeah, that's true. Yeah. Yeah, we'll take a look. Thank you.
Yes.
They know that.
Well, folks, another great meeting. Thanks.
Fernando?
Oh, yes, please.
Just one more thing. I put on the chat the information I think would be interested to the scientists anyway, is that the Congress is now considering the president's proposals for the budget for next year, which, as you probably know, included massive cuts for sciences in general, but also for climate-related work. The good news is that I haven't been through these 300 pages, all the 300 pages yet, but it looks like least the Senate anyway, the committee is kind of rejecting most of those and sustaining science and sustaining climate work research as we go on. A lot to play out with respect to the dynamics of Congress and so on, but at least that's some good news for today.
Hey, absolutely. Go Senate. No, thanks a lot for sharing that, Don. I think I saw it came out. I haven't looked at it myself, but the impression that I got is that they kept the funding level similar to fiscal year 24. So that's actually very, very good.
Yeah, I mean, just for example, they included a cut to NSF of like $60 million out of a $9 billion budget. So that's nothing like this we're thinking about.
So yeah, so hopefully fingers crossed. And now that the next stage is reconciliation with Congress budget. So it's going to be.
And our Senator Van Hollen, who's a member of that budget, that appropriations, is a very key player in that.
Yep.
They played a very important role. And this was basically a bipartisan agreement. They've got the Republicans to support this as well.
Yeah, no, thanks for sharing that great news. That's a really great way to end the week. All right, folks. Well, listen. So our next meeting, Rahat, refresh our memories. Next meeting is August.
1 second. Let me look it up. It's August 15th.
15th. Okay, so it's around the corner. So, so we'll send out an agenda. But now we're going to be focusing on. I mean, we'll continue having presentations, and there's lots of things to share and to learn. But more of our time to hone in on what we're actually tasked to do, right? The recommendations and the report and so on. Well, folks, thanks for joining again, and have a fantastic weekend.
Thanks. Bye.
Thank you, Sylvia, again.
All right. Thank you.